as I go along. Literally, this afternoon, I had another micro epiphany, if you will. It's not a climate model, and that is so important to understand the difference. And the reason for that is, I'll explain in a minute, but so the emphasis is on the metric at this point, and how we will measure climate change potential. And the metaphor I came up with is, if you will, the climate model that's been discussed here, and one of the common metaphors are automobiles. Climate models are like the design, the research, the technology goes into designing the engine, the powertrain, the steering system, the tires, everything that goes into the design of a car. But once that car is designed and it's out in the marketplace, the consumer has three inputs: the gas pedal, the brake pedal, and the steering wheel. All right. So the success of the car is the fact it could boil all that technology down to these very basic, common utility. Okay. The same things are true of Apple, the iPhones. Boiling down that incredibly complex interface into something that can relate to all humans. What I'm trying to do is come up with a very simple, common, broad metric for carbon that can be used literally for all carbon. So I call it the gas pedal metaphor, if you will. And it's, if you will, our objective is to manage climate change. It's not to eliminate climate change. It's not to, there are so many other issues surrounding climate change. I'm focusing on the reduction of temperature, reducing ocean acidification, if you will, the effects of carbon. And the term that I'm using is one of, instead of carbon fee or carbon tax, I'm using the term carbon toll to indicate a toll on carbon which moves in the biosphere and circulates. And so we're tolling the carbon as it moves around the various reservoirs. The most economic, my feeling is the most economic way to move off of a high carbon economy is to do it to the extent, the greatest extent you can, as part of the normal churn of the economy. When you're replacing plants, when you're buying new cars, when you're changing your investment, looking at that investment from a new perspective that incorporates some carbon externalized costs that are now being included in those investment calculations. From the Carbon Trust, this is just a diagram, I believe it was published in 2012, shows the embodied carbon flows around the world. And the idea here is that China is, as many of us already know, a large exporter of carbon throughout the world. Okay? But what I found interesting was that if you include carbon emission, embodied carbon, and you're looking at the UK, the statement was that over half of the emissions, carbon emissions included in consumption, arise overseas, okay, which again shouldn't be a surprise to anyone. But to me, I'm thinking, if you want to manage a system, how can you not capture half of your emissions? So my objective was, let's see how we perhaps can capture those emissions. These kinds of shifts I refer to as spatial shifts in carbon emissions. Okay, so you're trying to get away from the taxation by moving your exhausting of carbon to other locations where there are no taxes. Time frame. I'm looking at the investment time frame. In the short term, I think cap and trade will probably be the model of choice. But looking forward, when you have the additional degree of freedom of changing your investments, and you'll see in a minute what I mean by that, your measure of simple pounds of carbon released are not necessarily going to work. I want to try to capture global carbon atoms that are emitted to the atmosphere. What we need is a carbon accounting system, or put another way, a way of bringing those externalized carbon costs into our accounting system so that we can then book those costs so the financial and capital markets can see this, and investors can then have access to the capital markets to lower their carbon emissions. So the idea is, if you will, to augment carbon equivalence, which my understanding is the basic metric for measuring carbon emissions at this point. The present metric is a scalar, meaning we're looking at pounds, tons, kilograms of carbon that are emitted to the atmosphere. My objective is to change that to a vector. What do I mean by vector? Well, a vector has what? Both quantity and direction. So I'd like to measure, and my proposal, if you will, is to measure where the carbon comes from and where it goes. So right now we're assuming it's coming from, for the most part, from fossil fuels to the atmosphere. I call that movement a change in carbon quality. Okay? I've had to come up with these various names. I don't think anybody else are using these names, so this is for presentation purposes. But how do we do that? How do we measure that change in carbon quality to meet all the objectives that I've outlined so far? So, to try and capture all of the movements in red are anthropogenic carbon movements. I'm going to try to capture all of those. It seems like a tall order, but cap and trade right now is just capturing emissions from burning and combustion of carbon. What we can use, there is a common attribute that we can use for all this carbon movement, and it's very simply what I call residence time. You might, to clarify this a little bit, it probably should be defined as state residence time. The amount of time that the carbon remains in whatever state it's in. So if it's wood, until the wood breaks down and the little animals and critters come and devour it and turn into carbon dioxide, okay, that period of time would be 100 years for a tree. For carbon in the ground, coal, oil, natural gas, let's call it round numbers, 1 billion years. Every form of carbon, wherever it is on the planet, has, if you will, or you can use, or you can define a residence time. So it's a common attribute of all carbon in the entire biosphere. Okay, a little bit of background. This is a distillation column. I'm from a refining background, if you will. You look at these as different products that are coming off a distillation tower. This is how we use carbon. To a refiner, those are money streams coming off, okay? All right, and the important thing, one of the important things among many, is that the cost of what's going in has to be less than what you're getting out, okay? Another important thing is that what the refiner tries to do is he tries to take, this represents very heavy materials, long carbon chains, okay? Asphalt on the street, if you will, all right? At the top of the column, what's coming off, very light gases, ethanes, propanes, methanes, okay? That's coming out of that same barrel of oil, okay? But what the refiner tries to do is they try to use various pieces of equipment to change, generally speaking, to change the heavier components and move them up, make the carbon chain smaller, lighter, and they're more valuable. But it takes huge investment, huge research development, and an enormous amount of business risk. Yes? Okay. I'm going to have to move pretty quickly here, sorry. This is what the petroleum products list was in 1957. The same chart, going back to the 1900s, we had 3 products. So in half a century, we've gone from 3 products to maybe 100, 200. Today, half a century ahead, we have literally thousands of products. Carbon has become ensconced in our economy. We are in a carbon economy. So to get off of carbon, specifically fossil carbon, is going to take a very concerted metric to move us away. Okay? This is another distillation column. So going back, all of these I said were being looked at by the refiner as revenue streams. This stream right here will simply be looked at as a negative revenue stream. So what do? I'm going to try to eliminate or reduce the cost of that. And one way might be to take the carbon dioxide and convert it to biomass. Okay? Reduce the carbon dioxide. Okay? So these are things that people in the industry are going to do. I'm actually making a prediction here that we will see this. Example of the research that's actually been going on, if you will. But in general, the term that I use for all of these types of shifts of carbon dioxide, to other forms of carbon, I refer to them as temporal shifts in carbon emissions. Because eventually, what happens to this biomass? Eventually, it goes back, okay, into the atmosphere. It has a high free energy, and plants and animals, or just natural oxidation, will convert it into carbon dioxide. So it has a residence time as algae, but it's not going to stay as algae. It will go end up in the atmosphere eventually. The general category I have for this is temporal shifts in carbon emissions. So we have spatial shifts in carbon emissions, and we have temporal shifts in carbon emissions. So my proposal, that's it. This is how you measure, if you will. This is how you gauge. This is the metric that you use to put together a price system. Another way to look at it is the change in the carbon quality. And this is in effect what you use to price the carbon. So if you're going from coal oil natural gas, that has a residence time of 10 to the 8th years, to carbon dioxide, which is residence time that's already there, so it's a residence time of 0. Okay. You measure that distance. Now I happen to use the log, so if you take the exponent, 10 to the 8th minus 10 to the whatever, it's defined as 0, your delta is 8. So if you're going from coal oil natural gas to the atmosphere, your number is 8. Now different jurisdictions are going to price that 8 different ways. If you're going from biomass, which might, like wood, grass, might have a residence time of a year to 10 to 100 years. You're going from 10 to the 1st, 10 to the 3rd, so it's 1 to 3 to 0, so your cost would be whatever the difference is. And that's it. Now, there's a lot of, this leads you to a number of results and how it's used and booked. There's a whole system I've been developing, but I figured I'd just leave it here and let you ask questions and see if I can take it further. So, questions? Yes?
I guess you could use this for credits also, is that right? So, I mean, suppose I'm a charity or something like that that's dedicated to planting new trees. And these are supposed to do carbon sequestration, right? And so I can take what the residence time is of the carbon I'm pulling out of the air and compare that to what the residence time is going to be in the new tree, and that should give me the kind of credit that you can use in a cap and trade system as currency, right? And so these are supposed to be one-to-one. I can use that to buy out the deficits that I'm using. Is that right?
Absolutely.
Okay.
This can be used for any, and I underline any, anthropogenic activity that converts carbon from any form to any form. I'm still trying to digest what that really means. To be honest with you, I've been working on this for years. But any activity, forward or backward, which way you go, okay? I imagine that this is, however, just the first step in an overall valuation.
You have to figure out pricing.
There are going to be other things, I think, that, if you will be tacked onto this. I picture this as really the first dimension of a multidimensional vector which will develop over the years. The nice thing about this is it's simple. It's like the gas pedal. It's transparent. You can see what happens. It applies anywhere, anytime, any process, now, and here's the real power that this has. You can now evaluate any investment beforehand. So, any investment, any corporation, any country, any person, any entity can now be have a derived carbon, change in carbon quality measure, okay, using these. Right. But I also admit that I think there would be, if it were to go into practical use, there would be other things added to it later on. It'll become multidimensional, is my guess. But the power, if you will, is it covers all changes in carbon by, anthropogenic. The difficulty is going to be, you first have to determine what's the natural change in the natural carbon flows. So you have to determine, what's your starting point? What's your initial set of conditions? That has to be established. Once you do that, now that's not going to be easy, but once you do that, then you can look at all other human activities and say, okay, well, here's your base case, here's your change set of conditions, and then the change set of conditions using this metric gives you the, it's a relative number, not an absolute number. This also can be used to value embodied carbon, which then means that you can allow countries to implement their own carbon strategy. And then what you do is, when they go to export their products to other countries that have different carbon tax regimes, you can bring them up to what I call carbon parity at the border. So countries can have their own carbon strategy. Germany can be a high carbon tax, but when products come in from, let's say, zero carbon tax countries, they assess a fee and make it competitive, if you will, bring it to carbon parity with industry in that country, in that local country. And the reverse is true. You can give credits. So, I'm sorry, another question?
Yeah, so my question was, well, I feel like the kind of the new thing that you're bringing to the conversations about various carbon pricing schemes is taking account of the residence time of the carbon depending on what form it has.
Okay.
But what I wanted to kind of take a step back on and sort of understand better your critique of kind of the dominant way that we think about carbon pricing, where in a lot of policy discussions the assumption is, well, we set some floor price for carbon, where, as you say, that's going to be politically decided in different jurisdictions. But something that's generally understood is that the price of carbon is going to increase over time. So this does provide a price signal to various actors that, well, you need to be aware, about your investment decisions you're making now. In 10 years, the price of carbon, you can project forward what it's likely to be and how that's going to. That kind of puts the pressure then on individual industries and companies to substitute whatever inputs they're using for their production practices. Like that's kind of the way people typically assume that pricing carbon without necessarily getting into the worrying about this carbon quality that you're discussing.
This is no different.
Okay.
You hit on what I feel is an extremely important point.
Yeah.
One of the most effective taxes that you can impose on carbon is one that you never have to impose. What I mean is, if you tell somebody that 10 years from now, rather than $30 a ton, it's going to be $60 a ton, if they go away and they decide, well, I'm not going to do that investment, I'm going to do something which is less carbon intensive because of it. You've never taxed it, but they decided not to do it.
Right.
Because, and I have three words: caution, gradual, but steadily.
Yeah.
And what I mean by steadily is you announce your intentions. You have a whole plan laid out.
Yeah.
So that they can evaluate their investments over the life of the investment and determine whether they still want to do that. Okay. If they decide not to, you've never had to tax them. It never became an issue. They just stopped normal. That's part of what I'm trying to go. My goal is to work on is part of the natural churn of the economy, which I think would be the most efficient, one of the most efficient ways to reduce carbon emissions. This does very much the same thing. I'm not trying to. First of all, cap and trade will be fine in the short term, I think. It's when you get into this investment cycle of research and development where they can start looking at alternative ways of exhausting carbon other than carbon dioxide. Either as biomass or, who knows what they're going to come up with. But I'm actually, my main point is I'm trying to stop them from gaming the system, which I think is going to become more prevalent. Okay? This also includes things like carbon capture sequestration when you put it in the ground. Okay, it's not going to stay there as long as coal and natural gas naturally. Okay, maybe 1 million years, but it's not going to be 1 billion years. Okay, it'll seep out. The mean residence time is not going to be 1 billion years. It's not going to be kept on. The requirements, my understanding, the requirements for carbon capture sequestration is to have monitoring for 100 years. Okay, as part of the guidelines. But worry about cracks. Worry about carbon leaking back out. Let's put it this way. The way I look at it, if carbon capture sequestration, just pumping the carbon dioxide into the ground and trying to secure it underneath there, if that was really to work for 1 billion years, we'd have a lot more of it. You'd already have it, you see what I'm saying? But it doesn't occur, it occurs some places, but nowhere near the frequency of coal and natural gas. Okay. Nature hasn't captured it captured carbon dioxide as silicates, carbonates, if you will, but not as pressurized gas. So, thank you.
Thank you.
Sorry.